Hey everybody, Jeremy here. Welcome back to the Towards Data Science podcast. Today we are talking to Ryan Carey, who is at the University of Oxford's Future of Humanity Institute, where he works on their AI safety team. Now, Ryan's research is focused primarily on understanding the incentives that drive the behaviors of advanced AI systems. And those include systems like Twitter's recommender system, which arguably has an incentive to polarize its users to make them more predictable. And it also includes advanced AI systems of the future, of the kind we'll be leaning on if and when society reaches a point where AIs are making most of our day-to-day decisions. On top of Ryan's research, we'll also be talking about his decision to move into AI safety research in the first place, which is its own fascinating exploration. Ryan had a background in medicine before moving into technical AI safety. That transition came with a lot of fascinating trade-offs, including ethical and moral questions about the impact that he could make with his career, and I think they make for some fascinating listening, so I'm going to get out of the way and let you enjoy the show. Well, Ryan, thanks so much for joining me for the podcast.
Excited to be here.
I'm really excited to have you. You have such an interesting background and backstory when it comes to how you got involved in this AI safety space. And I want to start there because I think there's a lot that we can learn about your own decision-making process and the kind of thought process that leads other people into this space from it. Yeah, can you just give everybody the 101 on how you came to it?
Yeah, sure. So it's a long story, right? But when I entered medical school, like many people, I wanted to have a positive impact in the world. A few years into that process, I suppose, I was reaching my clinical years of my study, soon going to be like a medical intern. I started to encounter some thinking that had been happening online about what are actually more and less effective ways of having an impact. So one of these articles that I found really that was quite influential to me was from a guy who's now a colleague. He was then a doctor, now works on some biosecurity stuff, Greg Lewis, which was looking at how to quantify the impact of the career of a medical doctor.
What did you learn there? What were some of the big takeaways?
Yeah, so I guess it's like hard to know even how to start thinking about this question, right?
Mhm.
So one way to think about it is how much total impact can we attribute to the advent of modern medicine? So nowadays in US, UK, these kind of Western developed countries, we live maybe 80 years. Probably before modern medicine, we only lived half of that. And we have maybe one doctor per 300 people in our population. So you could say that the career of a doctor, maybe it's saving 150 full lives.
I see. So yeah, half of people's lives on average across 300 doctors.
Right. At least that might be your starting point. But what Greg did with his analysis, he went on with that and he just ran with it. So he thought, actually, how much of this 150 lives is from other things?
Mm.
It's from better hygiene, so there's less infectious diseases, maybe better education, other health professionals, nurses, and so on and so forth.
Mm.
And he managed to kind of whittle down that number by reading a bunch of papers and carrying out this analysis. And he figured that maybe you only save, maybe, of course, it's like every life that you save is fantastic, but maybe it's more like 10 lives over the course of a full medical career.
I wonder also if, do you think that there's something to the cultural, there's almost this like cultural value that we have where we venerate doctors, and I think rightly so. I mean, it is a dirty job. It is a very difficult job to do, doctors and nurses, um, and because we have that through this lens, you could argue slightly even irrational level of veneration for just the impact that some of these folks can have. That causes more people to do it, which is itself an instrumentally good thing. It's useful to have that myth that even if it's slightly misguided, leads to more doctors and more nurses.
Yeah, I mean, I totally agree that it's kind of like we want to have a lot of doctors and a lot of careers you don't have an impact at all, or maybe you have a negative impact
Mm.
in some careers. Um, but that was kind of a part of his analysis as well, is he thought about for 1,000 people, how much help is there from the first doctor that you have in that population?
Mm.
And then is the impact the same when you add the second doctor on top of the first? Probably these returns have to diminish. So that's part of kind of the calculation that he does.
That gets you to the point, I guess, where you realize, okay, maybe medicine doesn't have quite the scale, the order of magnitude of the impact that I might have thought it did. It's certainly a good thing on net, saving 10 lives. That's nothing to snuff at. But what gets you to explore the alternatives? Like, what alternatives did you consider at that stage after reading that?
Right. So I guess around that time, there was coming to blossom this effective altruism community online that was kind of dedicated to trying to address these questions.
Mm.
Uh, some of the suggestions, they sound pretty crazy, I guess. Like maybe you should go and start a hedge fund and then donate those funds to try to employ more doctors, maybe, in the developing world. Maybe instead of kind of going to the clinic, you should instead be doing like public health campaigns to try to reach like a larger scale of people. So I guess like this threw the window wide open for just considering a much wider range of possibilities.
That's interesting because I have found this with a lot of people who focus on career impact and trying to figure out how can I actually change the lives of as many people as possible? How can I improve quality of life across the board as much as possible? I often find that the ideas they come up with do to the average person sound crazy, and yet when you look at the numbers, like the arguments are often quite clear. You point to the hedge fund example; it's sort of an extreme one, but there are certainly others that sound similarly out there. Do you think there's like a reason why? Like, why is it that we tend to kind of revolt against this notion of very scalable impact?
Yeah, I guess one argument for why this might be is that it's based on like a psychological phenomenon of scope and sensitivity, which is that if you think about saving one life, you think that's a miracle, especially if it's like an identifiable person. It's like a face on a brochure or something like that. But then you think about saving 10 lives. Would you really want to pay more to a charity that claims they can save 100 lives? Like, of course, it
Mm.
makes sense, but many people aren't going to find that to be an intuitive calculation.
Yeah, that when you what is it? When you kill one, it's a tragedy. When you kill 10 million, it's a statistic. Something like that.
Exactly, exactly.
Yeah, and that I guess leads you somehow. It leads you to AI safety. I think I know why, but can you sort of expand on what that thought process was like? In particular, why AI safety and why not? I mean, there must be so many other options. Why did you land there?
Yeah, and this is also something that's not going to be intuitive to a lot of people. I think it really comes down to an idea called existential risk. So it's one of these. It's a relatively new philosophical idea, which is that maybe we should pay particular attention to catastrophes that have the potential to kind of foreclose or diminish humanity's eventual potential. So, okay, that's obviously a mouthful. But one way of thinking about this is a thought experiment from Derek Parfit, who was one of the great English philosophers of the last century. He asks us to consider three possible outcomes. Outcome A is that no catastrophe happens. Outcome B is a catastrophe that kills 99% of the population. And outcome C is a catastrophe that kills 100% of the population of humans on Earth. I don't know if you've heard this one before, but I think the idea, right, is that obviously we prefer A to happen to B to C. But there's this question of whether the difference between A and B or the difference between B and C is larger.
I find myself my first reaction is like, oh, it's 0.1% or whatever, of course. And I'm sure everybody's reaction initially is going to be that. But when you think about it, it really is the difference between some form of existence for humanity and none. What I guess can you explore your thoughts on that argument and where you land on it?
Yeah, so I think I'm kind of on the same page as Parfit with this example. Uh, I think that maybe to the people who are alive at this time, the difference between A and B is the larger difference.
Mm.
But if you really consider that the number of people who could live on this planet for the next century or for the coming centuries or for multiple planets or whatever, it could be much more than those that currently exist. uh, I think that's what makes me feel like the existential catastrophe element is really the important one.
Yeah.
So, I mean, if you believe that this argument, which I would recommend to people to maybe stew on it for a while, but if you become convinced, then it really has quite profound implications that focusing on possible existential risks could be a more useful way to allocate your time than even the most severe current catastrophes.
Yeah, it's fascinating how important this idea is of the discount rate that we apply to the value of life in the future relative to now, and just how much time seems to matter in like any kind of ethical or moral decisions we make. I often think about that like we'll get into this I'm sure, but in the context of like recommender systems. There's this notion that you're a certain person when you start interacting, let's say with Twitter. And then over time, the Twitter algorithm will change you by showing you different kinds of news. And to some degree, you actually want it to. You want it to educate you, you want to be a better person. But maybe it'll brainwash you. And then at time T2, like at that moment, you'll actually be thankful for the brainwashing. And so, do you owe respect to the initial version of yourself or the future version of yourself? How do you balance those out? And what right do we now have to kind of dictate the course of future affairs? It sort of seems like it's all entangled in this very complicated complex of different ideas and moral outlooks. But you tend to lean towards the sort of future, sort of emphasizing the value of future life, roughly on par with present life. Would that be fair to say?
I mean, yeah, so I guess that I would want to say that if you can if you can create happy lives for your future generations, such as your children or grandchildren, that you would want to. It would seem hard to come up with a reason that you should give special privilege to yourself over those future people. I guess you can also draw an analogy to whether you want to give special privileges to people who happen to have been born in your country compared to people who are less fortunate in another.
Mm.
So you might want to treat those cases in the same way.
Interesting. Okay. So this leads you to focus on existential risks. So you're like, all right, I want to look at this to see, presumably, if there is a case to be made for this kind of risk. I imagine there are a lot of different classes of risk you could have focused on. What brought you to where you are now?
Yeah, so I mean, this right now, I really feel like maybe I should have chosen a different kind of risk in
Oh, really?
2021. I mean, if you look around, if you look at the world around us, what's the biggest risk that's
Oh,
happened?
yeah, yeah, global pandemics, that sort of thing, eh?
Yeah, especially as a doctor. So
Right.
maybe Greg beat me on this one,
Well,
but I can still tell you what I was thinking.
yeah, yeah. Well, by the way, I am curious about the pandemic thing though, because to me, it really seems like that's much more of a 99.9% annihilation risk than a 100% annihilation risk, because I imagine you'd have like isolated tribes in Borneo or something. Like some humans are going to survive almost any plague.
Yeah, I mean, I think probably there's going to be more biocatastrophes, but then like maybe it's a little less likely that they could be an existential catastrophe because yeah, maybe there's some guys on a submarine or whatever.
Hmm.
I think Toby Ord, he is a colleague who wrote a book on this topic, and he did estimate the risk from AI as at least a little bit higher.
Oh, interesting.
The
Okay.
existential risks.
That brings us to existential risk from AI and why you decided to focus on it.
Right. Um, I suppose none of us really know where AI is headed. We, it's hard to say whether we're going to get to human level AI, as was the original goal of this AI field, uh, and it's also hard to know whether it's going to be possible to do that safely, to have kind of systems that are as smart as humans or smarter than humans and still be able to kind of coexist.
What I find fascinating about that is like my brain has two reactions when you lay out that high level case. The first is this is so obviously true that it doesn't even need to be stated to some degree. And the second is this is so obviously crazy that it can't possibly be true. And I think there's sort of this fascinating contradiction where I don't know if this is like normalcy bias, but we're used to the world looking a certain way. We have AI systems already, some that are quite advanced, at least, well, by today's standards. And we haven't seen a giant AI catastrophe. So it almost feels like the status quo must be maintained. Is there a particular thing that you found helpful in terms of explaining to people why it is that this is really something we ought to be concerned about, that things could shift quite quickly potentially in the future?
I think maybe our experiences with COVID are actually an example of that, because a year ago, in March 2020, I feel like I felt the normalcy bias myself, where I feel like I couldn't believe that our world was going to change anything like the way that it did. I really wanted to feel like surely it'll not escape China, or surely it'll,
Yeah.
there'll be a few cases and then they'll go away. And it just, it just didn't happen. Um, One more specific kind of way of thinking about this in AI would just be to think about um, what are the changes that we notice as AI does get more capable, and that have started to happen with the AI that we see today. And I think, I think that's something we'll get to talk about, is kind of how, as you give AI systems more responsibilities and these AI systems are more capable, then risks are something that you increasingly do have to think about.
Maybe we can jump into it right now because I'm just really curious about some of the examples you might have there. Can you point to some and how this is manifesting today?
Yeah, absolutely. So I think if you think of maybe recommender systems on Facebook, uh, we could talk about some of the ways that some of these systems might have more responsibilities and broader objectives than others. So if you have a Facebook algorithm and its responsibility is to give you a post in order to have a high chance that you will like that post. Uh, this kind of system, it does have some perhaps undesired incentives. It might send you clickbait, but maybe there's not such like deep or profound concerns about it. In contrast, you could consider another kind of recommender system, which is tasked with suggesting groups for you to join to maximize your utilization of the app, your time spent over the coming month. Such a system, it actually does have more kind of elbow room, more ways to achieve its objective. So it could send you radicalizing content, which you are going to change your values and change the future content that you click on. And basically it has more room to plan. And so then the incentives become something that we have to more worry about.
And is this something that we're seeing? I think Stuart Russell, if I recall, made an argument along those lines. Do we have evidence that suggests that that is actually now going on at the level of, I don't know, Twitter or Facebook or other recommenders?
Yeah, so it is true that there was some whistleblowing in Facebook itself. Um, in a Wall Street Journal article a few months ago, there was a case that they said, and I can quote directly, that they said, "Our algorithms exploit the human brain's attractive to divisiveness. If left unchecked, more and more divisive content would be shared in an effort to gain user attention and increase time on the platform."
Wow.
So there's definitely some concerns, but how extensive it is, how serious this problem is right now, I think is still up for grabs.
Yeah, I guess it's arguably a problem of sort of social fabric. And again, at worst, I can imagine that leading to, a 99.9% or a 50% catastrophe or something like that, where humans turn on each other, which is definitely concerning and something that I would totally agree spending a lot of time on. What's the next step now as you look forward in time to, for example, like getting really to that existential risk threshold? Like, where do we get there with AI?
Right. So I think you can kind of see the same trend in any kind of area that you apply AI to, that kind of a broader goal and a more capable system means greater risks. So you could also say for a stock trading system, if you just say pick a stock that's undervalued, not much problem. If you say go nuts over the next month and make me as much money as possible, you're risking market manipulation. And if you say, choose me the best chess move, that would win if you were playing against yourself. Not so much problem. But if you say, win as many chess games as possible, then you're implicitly creating an incentive for the AI system to, make 1 million chessboards and find 1 million opponents and open-endedly pursue that goal. And the question is, where does this end up? You could argue that as you just have a system that is kind of open-endedly ambitious and open-endedly powerful, that such a system might want to take away control from human operators, or it might, completely oppose their values in pursuit of some other objective. And this is something that Stuart Russell has talked about. So he raises like a toy example of where you have some kind of personal assistant robot that receives one reward if it succeeds at getting you a coffee, and it receives 0 reward otherwise. And I guess we abstract away all of the details of this scenario. If such an AI system, it's possible for a human to, in the intervening time, turn the system off, then it's not going to be able to get that one reward. So that's going to be an undesired outcome. And if there is a way for that system to turn off the human beforehand, then that there would be an incentive for the system to do that. So it's very scary to think about where this could end up in kind of some sort of worst case scenario.
Then the idea is, so you reach a point where essentially the system is intelligent enough to come up with solutions to the problem that you gave it as stated. The problem is like, hey, get me some coffee. And it goes, okay, I can get more goodness points by making more coffee. And then the big risk is that we'll misspecify our goal. Like, it's really get me more coffee. And by the way, along the way, don't kill me, don't deactivate everyone around me, don't destroy the entire planet in order to maximize the amount of coffee you can make.
Right. So yeah, that's exactly right. I would say that AI safety problems, they are going to tend to arise whenever you have an AI system that wants something that's slightly different from what you wanted. And that may be because you weren't able to say, oh, don't go about market manipulation, or you didn't think to write down that, if you shut down, that's also a perfectly satisfactory outcome. But that our ability to supervise this unaligned system is kind of outpaced by the capabilities of that system.
Speaking of supervision, I mean, that's a huge theme, obviously, in the AI safety community. It seems like something that'd be really, really hard to do, because you implicitly are dealing with, in these scenarios, like an AI system that is more intelligent than a human being. So it's sort of like having a child supervise an adult and trying to get it to not do stuff that would, in the long run, be detrimental to the child's health or safety. What are some of the techniques that you think are most promising in that direction? What are some of the things, especially, that you've been working on?
Right. Yeah. So I think there is just a vast number of different ways that you might want to supervise an AI system. You might want to have better transparency techniques. So basically that you can understand on a neuron by neuron level what the AI system is doing and why. You might want to have some kind of trigger where if an AI system is up to any mischief, then that will just be detected. There is, I guess, some ideas about like aiding the supervision of AI systems with other AI systems. So it's kind of like the AI system might be like one level smarter than you, but if you have an AI system that's 2 levels smarter than you and it can explain to you what the other guy is doing, then there would at least be some hope that you could keep pace in that sort of fashion. So I would say there's like absolutely a wide gamut of possibilities. But the one that I've been looking at personally is coming up with automated methods to understand and describe the incentives of these AI systems.
Interesting. So the incentives of these AI systems, what determines those? Like how does an AI system? I guess first off, I guess we give it a set of instructions, right? We tell it, hey, I want you to make me some coffee, for example, or I want you to maximize the number of minutes that users spend on Twitter or whatever the platform is. The worry is that in reality, those incentives will differ from what we actually deeply want the AI system to do. How do we detect those differences, or how do we figure out what the true incentives of these systems are?
Yeah, so I think how to detect the differences is maybe a complicated question. But to begin with, we could just ask, how do we detect the incentives in the first place?
Hmm.
Or even a step further back, maybe we should be saying, um, what are these incentives at all?
Hmm.
So to begin with, I guess I'm conceptualizing an incentive as meaning that it's something that an AI system has to do to achieve its goal, or something by the same token that a human has to do to achieve their goal. And that this kind of situation can arise when there is both an event that's both possible and beneficial
Hmm.
for an agent. So I guess to start with some human examples, suppose you're trying to like buy a phone for the cheapest possible price. Um, the price tags of these phones, they contain valuable information. And if the prices are visible, so you're able to discern them, then you're going to have an incentive to respond to those prices. Um, so in the case of an AI system, this kind of concept of a response incentive, um, you could say that in a safety context, you would want to have an AI system that is responsive to the value of its shutdown button, that
Hmm.
shutting down when asked helps it to achieve its objectives.
Okay, so response incentive is like something I have, if I'm the AI system, it's something I have an incentive to track, to keep track of, to monitor. If I'm an AI system that's like trying to learn about physics, I attend a bunch of lectures, I have an incentive. Let's say my long-term goal is to do well on the exam, I have an incentive to like watch the lectures unfold. So that's like
Yeah,
one category. Okay.
yeah, that's one kind of incentive that we've talked about.
And what are some of the others?
So another kind of incentive that we've talked about is an instrumental goal. So to start again with a human example, suppose that you're trying to sell electronics, and to get a bonus salary, it's valuable for you to control the customer's purchases. If additionally, these customers are walking in the door who you can, and they're customers that you can influence, then that's going to shape your behavior. And influencing those customers is an instrumental goal for you.
In the example of Twitter or Facebook, this is the algorithm has an instrumental goal to some might say like polarize people in order to make them easier to predict on. Like if hardcore like leftists and hardcore rightists like tend to have very well defined sets of views and tend to click on all the same articles, you basically take like I guess a spectrum problem and you reduce it into just like this categorical one or zero, and that would be the incentive.
Yeah, exactly. So you could say that Facebook has an incentive to polarize or addict its users, or that like a trading algorithm might have an incentive to manipulate the markets.
It's fascinating to study like what these incentives are and to understand them deeply, and it's clear why that would be valuable. I guess the next step would be trying to detect those incentives, to realize when they're present, because I imagine you'll have like some systems that are just so horrendously complicated. I'm imagining now Facebook interacting with Twitter, interacting with Google, all under one hood or something, where it really wouldn't be obvious, at least to me, like how you would untangle that web. Is there like a process people can follow, or is it too early to start talking about complex systems like that?
Yeah, so we're only at the beginnings of this kind of process of figuring out how to evaluate these incentives. Um, I guess one kind of system where we might have a better chance at this is if we know that the system is using a model and we can ask it certain types of queries.
Hmm.
So if we can ask the Facebook group algorithm, um, if the human user was less polarized. So, if you didn't polarize them by setting into this group, would you still do it? Uh, at least conceptually, that's kind of the question that we're trying to ask. But turning that into a reality is going to be a long research program.
Right. Yeah. It seems like it runs up against this idea I've heard come up a lot in AI safety, which is that abstractions are leaky. So to take Facebook, we have the concept of polarization. Polarization is like an idea that we express with words and and kind of tell stories about in our minds and imagine. But asking, like, trying to codify that into language, if you will, that's comprehensible by an algorithm, or worse still, trying to notice when particular abstractions are being used by a machine in the first place. Like that seems like a huge open problem. Are there are there efforts underway to try to figure out that aspect?
Yeah, I mean, I just think this is a massive and very daunting problem. I guess one scenario where it comes up, that's like a kind of toy example, is you could say, suppose you do have an AI system that um, it is responsive to its shutdown button, such that, when the button is pressed, it will shut down. When the button is not pressed, it'll go about its business. That doesn't necessarily give you a guarantee, because an AI system might be able to kind of create a wall around its button so that it's never pressed.
Right.
And so I guess you might have designed the system with the idea that this button is like this sacred abstraction. But the true entity that we cared about was not just the button, it was some kind of larger apparatus which has like a human in it, and humans' values, and like an ability to not have a wall in the way.
Yeah.
So somehow we need to just keep chipping away and keep thinking about how can we make kind of designs that are more robust to wrong abstractions.
It seems like fundamentally we keep running up against this idea that, well, you just didn't think of this approach. Like you just didn't think that the machine could build just like a box around its switch. And let's say you tell it, okay, no boxes. Okay, next thing is, I don't know, like some electric field that it sets up to zap anything that comes too close. Or you can almost imagine this like endless set of possibilities, many of which humans would have no hope of thinking of because they're so abstract, so convoluted. It's like 3D underwater chess, and you're just trying to frickin' get this button to work, but it's not that trivial. Is this something that you're optimistic about? Like, do you think this is a solvable problem?
Yeah, so I think it's messy, and it's kind of goes to some pretty deep philosophical issues, which makes me think it's not such an easy problem. Uh, I think this kind of concern is maybe what maybe one of these major ideas that can turn people off um, old-fashioned AI,
Mm,
um, and old-fashioned AI approaches to safety, that have like a discrete button and that the AI that rely on the AI using a model, and turn people towards more machine learning approaches. And I think this is just as true for maybe capabilities as for safety. That if your AI, its capabilities rely on it, like having a concept that you hard coded into it, then it might be that just means you're doing something wrong.
that's the thing. I mean, I guess abstractions, things like buttons, things like apples, like concepts that we carve out special sacred space in our minds for, are, I mean, they really are arbitrary. If you looked at the world the way it really is, it's a whole bunch of quantum particles fundamentally that are just happening to dance this dance based on the laws of physics, and everything is a mess. Like it's not clear where the apple ends and the air around the apple begins because atoms are exchanged back and forth. It seems like a real challenge. Is so the field of research you're working on right now is this incentives piece. Do you think that, like, do you see it as one component? Like, are we going to end up with a leading strategy that forms the backbone of our AI safety approach, hopefully that will one day be successful? Or is it going to be this like smattering, the salad of different kind of half-baked ideas that together hopefully give us enough robustness to survive this?
it's right now, the way it feels to me is like an investment problem. Like we just want to allocate some people's time to machine learning approaches, some people's time to like off switch questions, some people's time to fundamental theory. And, if we knew, we might all flip.
The different kind of portfolios of the portfolio of approaches here, where we have some short-term stuff, some long-term stuff. I think that'd be useful to explore, especially if some people listening are less familiar with what the different attempts to solve this problem have looked like and do look like. You're working on one subset of this space. Obviously, everyone is specialized, but what's your sense of like the overview? What are the different camps right now in terms of where people are focusing on this problem?
Yeah, I mean, that's a big question. So I think we were getting toward touching on some of Paul Christiano's stuff that he had done in his time at OpenAI. And there's kind of like these learning approaches. And I think maybe the canonical example of that was this noodle experiment. At least that's what a lot of people call it, where you have this kind of like virtual robot, which it looks kind of like a noodle. It's like kind of like a leg and a foot, all right?
Mm.
And Paul and his collaborators, they looked at how in this kind of simplified setting, you can convey a fuzzy goal, like a fuzzy abstraction to this robot. And they chose basically to try to train this thing to do a backflip. And like, it's not super easy to see how you would hard code such a goal. It's not just like, maximize your distance that you cover to the right or like rotate or something. There's some kind of like fuzzy, like there's some kind of fuzzy quality to it about what it means to us to have an AI system do this thing. And the way that they trained it to do this was like to get the AI noodle to like produce two random movements. And it might just be like a little bit of a twitch on the one side and a little bit of wobble on the other side. And to show those to a human and to let the human say which one is closer to a backflip. And to basically repeat this process with taking that feedback into account, adjusting, producing a couple new trajectories until you're done, until you have a backflip. So I guess that's like one kind of universe of AI safety research, which is trying to learn these fuzzy values using modern machine learning. So that's like one picture. Another picture, I would say, is the kinds of things that I've been talking about with these like incentive concepts, where I've been working with like Tom Everett and some other guys at DeepMind and some colleagues at Oxford on that. There's maybe a third kind of approach out of Berkeley, which is based on learning human values. And that's kind of maybe somewhere in between.
Mm.
And then, I mean, that's just the start. Then there's like a lot of individuals and other little organizations that are trying their own things.
That's a great kind of summary overview of the big perspectives. I seem to remember as well, like back in, this was like, I don't know, 2010 or something. One area people were trying to figure out was like, are we even going to, well, deep learning wasn't even a thing back then. So the question was like, what form will AI take? We don't even know what the algorithms are going to look like that will get us there. We just know that, something in our brains is allowing us to be intelligent. So presumably intelligence is possible and can be synthesized. And at that time, I think the focus was on using like decision theory, and I guess in those frameworks, the idea really was to use sacred abstractions. Like there were concepts like apples and tomatoes and things like that people would throw around. Is that more or less, has that been abandoned at this stage? Are people focused on like deep learning and reinforcement learning based systems almost entirely now?
Yeah, so I guess there has been maybe some of the very first work done on long-term AI safety was coming out of Machine Intelligence Research Institute in California. And I guess they were thinking about some of these some of these old-fashioned approaches to AI that are maybe like spiritually related to the things that I'm working on now. And they, I think, have also been working on more, I guess, fundamental perspectives on how to think of an ideal decision maker, including decision theory, which tackles various very abstract issues like how you should make decisions if you might exist in multiple places at once, if you don't know if you're in your body or if you're in someone else's brain, and they're modeling you, and these kinds of very difficult questions, as well as questions about how an agent should think and act if it's able to modify itself. So I guess this kind of stuff from Myriad goes even further in the theoretical direction than the kinds of things that I do.
Yeah, it's interesting to see that mix because again, the time dimension becomes really important, not so much time in terms of the way we were talking about it earlier, which is like, who's important, people now or people in the future. But it seems to me that there's another through line, which is when are we going to hit AGI, like artificial general intelligence at something like human level? And then people's thinking on that determines which strategies they tend to focus on. If you think it's going to happen tomorrow, then like everything you're going to do is going to be focused on deep learning systems and reinforcement learning. You might, if you have a longer time horizon, maybe you're more open-minded. Do you have a view on that? I know everybody has a ton of caveats that they have to throw out there, and I'll consider your caveats accepted. No one has a clue when this is going to happen. Having said that, when Ryan, do you think AGI is going to happen? No, but do you have any guesses or anything that kind of guide your intuitions when you're thinking about that sort of thing?
Right. Yeah. And like, I think it's kind of embarrassing to even try to say, hey, here's what's going to happen with AI. Because like, who should listen to me or who should listen to anyone about such a difficult question? But let me share a way that I like to kind of think about this problem, at least. So one way to divide up the problem of when we might be able to get to human level AI is to consider, in the current paradigm that we're in, this deep learning paradigm that we've been in for the last like 9 or so years, how many times would we have to repeat that kind of progress in order to get to AGI? And then to secondly think, given what we know about the basic economics of our situation, how much longer can we keep doing what we're doing in terms of the funding and compute and personnel that we're investing to achieve progress within this paradigm?
And what are the answers?
Yeah, so I think that for the first question of how many more times you have to repeat the last decade of progress, people would vary, to be honest. Like, I think GPT-3 is kind of like the most impressive thing that I've seen so far. And if you think how many more times would I have to go from these like convolutional networks of 10 years ago, which could do great image recognition, to GPT-3 in terms of capabilities, maybe it's like another 1 to 5 times over that we would have to do that. As for the second part of the equation, I think one like deeply neglected fact about the situation that we're in is that over the last 9 years, the size of these experiments in terms of the raw usage of compute has increased by about 1 million times based on an analysis out of OpenAI. The biggest experiments being things like AlphaGo Zero, which cost $10 million. And often these biggest experiments being some of the most impressive results, like GPT-3. Right. So just in terms of, like, this is way faster, this 1 million times increase, it's way faster than the prices have been going down for compute. And in terms of almost any economic development, it's just like quite astounding that you could just jump to investing so vastly much more compute and financial resources.
So you'd expect something like, I mean, if we're at 10 million, I heard similar estimates thrown around for GPT-3, anywhere from 1 to 10 million for training. Plus, I guess you do have what's interesting too here, it's a different kind of economic regime because you're moving then from the main expense being the expense of the researchers and their time, to now really the horsepower is starting to become the limiting factor. So you're saying basically 10x a year over the last 5 or 6 years, we've been seeing this go up. We're at 10 million now. How fast is compute getting cheaper too? Because I guess those are two curves, and at one point I imagine what's going to matter really is that compute curve.
Yeah, so yeah, 10x as much compute every year or two is right. Um, Now, as for Moore's law, the decreasing price of compute, it's much slower. So historically, there's things become 10 times cheaper every 4 years. Um, and despite maybe the hype about multi-threading or like using GPUs or TPUs, this has been slowing down rather than speeding up. And in more recent times, it could be as much as like 12 years that have to pass before you can get things to be 10 times cheaper. So I would say really that it's mostly, if you're trying to answer the second question, which is how much further can we keep investing more and more, it's mostly a question of how much money can be invested.
So that ties back to like basically something like, have we reached liftoff a liftoff velocity with respect to the actual abilities currently of systems like GPT-3? I guess if GPT-3 can generate, for example, enough economic value that they bring in more money to allow themselves to keep scaling. I guess even that'll have a cap because we don't have companies bigger than Amazon nowadays. It seems like 1 or 2 trillion. Who knows where it'll be in a couple of years? But presumably then that becomes, it's interesting. We're sort of like working our way through different regimes of economic dynamics here. When you integrate those together, again, obviously all this is incredibly fuzzy, but do you see something on the order of years, decades, within the century? Like if you had to sketch out like a probability distribution, I know a lot of people in this space have done that. What might that look like?
Yeah, so I guess I'll get to my probability distribution, but I think in order to say things, it's often useful to at least make some assumptions. So if we are in a world where I guess AI takes over the whole economy, but not only that, it like substantially grows the economy and completely reverses this maybe gradual slowdown that we've seen over the last 40 years, then I guess I can say all bets are off. Like this kind of analysis that I would be performing is not really going to be
Yeah.
valid anymore in that regime. Um, but if that doesn't happen, and you're in more of a kind of quote unquote normal regime where the US is not going to spend more than like 1% of its GDP on one AI experiment, and the GDP is at like, something in the vicinity of its current levels, then you can't keep doing these experiments beyond the next decade. And you might run into the financial limits of growing these experiments as soon as 5 years from now. Now, where does that place my distribution? Well, I mean, I think that it's reasonable to say that there's some concern of, that you might get to AI with like a final like hurrah in the next 10 years. But to me, my gut feeling is that that's not what's happening in the sense that we're not so close. So then I guess any time over the next century, maybe AI as a field has been with us since the 60s for 50 years, and you could imagine it might be with us for another 50. But I'm very uncertain.
Yeah, I mean that seems to be the through line. The only consistent thread that I get from talking to the more people know to talking to people who are really in the know is like that uncertainty. I mean, it is so hard to predict. Does it make sense to hedge against something extreme, like let's say 5 years? I know, for example, Sam Altman, the one of the founders of OpenAI, or the CEO now of OpenAI, I think he tends to hint that something like 10 years is his sort of horizon on that. Of course, he'll be optimistic. He's working on this stuff. He's invested everything he's got in it. But like, do you think that it's worth thinking about a 5 year horizon as an extreme case? And what would you recommend people focus on if 5 years was if you knew that it was going to happen in 5 years? What should we be doing in that scenario?
Yeah, so I guess I don't place a huge amount of weight on 5 years, but I do agree that it's like a reasonable question to ask, what we should be doing to hedge about that possibility. Uh, to be honest, if I think that it's going to happen in 5 years, I would be focusing more on deep learning based approaches,
Mm.
um, such as just using deep neural nets to like learn how to like intuitively do what we want them to do. And I would be kind of trying to work really hard with state-of-the-art systems like GPT-3 and try to get it to kind of answer questions in a satisfying and value-aligned way. Because then in this scenario, the eventual systems obviously are more likely to be similar to the current ones.
And do you see? I mean, I've heard the argument out of OpenAI that for similar reasons, they see a shorter time horizon, maybe 10 years. So to them, aligning GPT-3 or GPT-N as more iterations come out, that's going to be some kind of iterative process. And the hope is that we can sort of like iterate our way to safe AI. Is that something that my intuition on that is that seems kind of dangerous because this is, I'm sure, is too simplistic in many ways. But I imagine that there's a pretty significant step that you might go from a system that's really not dangerous to a system that's, yeah, really super dangerous fairly quickly, in like roughly the same way that from monkeys to humans you have a pretty sharp evolutionary transition. I mean, my analogies here are super muddled, and I think it reflects the general uncertainty that I have about all this. But if we're playing this iterative game, it seems like there's a risk that the next iteration might actually get us to something materially more dangerous than what we saw previously. So no matter how happy we were with the stack beforehand, you're always going to discover problems at the last minute. It seems to open up a pretty big gap, but I could be wrong. What are your thoughts on that?
Yeah, so I think I could take this as like a hypothetical scenario of, instead of saying, what if things happen in 5 years? We could ask, what if things happen suddenly, whenever they happen?
Right.
And we have basically a capability jump that, although perhaps smooth, is really fast over the period of some 6 month window. I think in that scenario, I would like the more theoretical work more, because I guess theory is what lets you predict systems that you haven't seen before. And so in that scenario, I would really want to have like a solid conceptual understanding of what system I was building before the sort of takeoff happens. But also I would think that's just a tough
Yeah.
one.
Yeah, I mean, it seems like you're trying to align something where the target is so far away. I mean, you need to get that perfectly right. So it seems like from the portfolio picture, then, and it's really interesting. I mean, obviously, we've had a lot of conversations on the podcast with people in this area, and different people tend to view it differently. They focus on different parts of the sort of quadrant between, it's going to happen very soon, it's going to happen very late or never, and it's going to happen smoothly, or it's going to happen all in one jump. It almost seems like those four quadrants, or those four, the interactions between those two dimensions, when it's going to happen and then how fast it's going to happen, are probably the most decisive elements to this. Are there any other factors or considerations that you think are really formative in terms of deciding what approaches to take or favor?
In terms of breaking up the AI safety space, that's probably going to be pretty predictive. Yeah.
Okay.
I guess another one, I mean, we mentioned this like old-fashioned AI versus machine learning distinction. And another one is more just circumstantial and practical considerations. Like, do I want to be a professor, or do I want to be at like a little Bay Area think tank?
Right.
And that's going to guide like what kinds of research you kind of allow yourself to do.
Well, and circling back then to where we began with existential risk and this idea in general, one theme I've also seen is people will talk about how AI is not the only existential risk. And nonetheless, it's the only existential risk that might help us mitigate the others. And so there's a certain kind of accelerationist impulse where some people will say, yeah, I know that there's a risk with this, but if this is what it takes to make sure that we have, no bioweapons risk, no nuclear weapons risk, that we can solve all these problems, then it's worth it. Would that be your take? Is that part of the benefit, let's say, that you take quite seriously in that direction?
Yeah, I think that's maybe one of these other little factors that push me towards AI rather than other stuff. Um, it's like an existential opportunity. It's- I think there's a bunch of phrases like that people use like that, or it's a you catastrophe.
It's a you catastrophe. Okay, great.
It's existential hope. That's the other one.
Oh, existential hope. I like that. I mean, to me, that actually seems like an important aspect of this. Almost psychologically, I feel like these discussions are they're taxing, they're difficult, they're stressful. So injecting some degree of hope, probably not a not a bad thing on some level. Um, awesome. Well, on that note, is there anything that gives you particular hope in terms of the progress you've seen on the AI safety space, in the AI safety space, AI alignment more generally?
I mean, I'm just astonished with how well this like little research community has done in the sense that now when we submit our papers to these conferences, there's often like an AI safety category. So we can send our work to be reviewed by kind of experts. And now so many of these young, talented people are now in the tenure track at top AI schools like Princeton and MIT and Cambridge. So I think it's just awesome, and we've just got to keep going.
Awesome. Actually, on that note, I'll say on Twitter, I think I learned that there were two guests we had on the podcast who became tenured professors shortly after we recorded the episodes. One was Dylan Hadfield Manel, and then the other was David Scott Kruger. And so,
I mean, they would say tenure track, but not far away.
oh, sorry, tenured track. I'm sorry. Of course, yeah, yeah. Well, hopefully you're next on the list, and we have a whole bunch, a whole bunch more to celebrate. I really appreciate it, Ryan. This is great.
That would be a while away, but yeah, great to talk to you.
Yeah, yeah, it's same here. And actually, I'll share some links. I think so. You do have I think you have a personal website, right?
So for our research agenda, we have a website, causalincentives.com.
Right.
And on Twitter, I'm Ryan Carey AI.
Awesome. I'll include those links in the podcast. Thanks so much.